Once upon a time, about 27,000 years ago, ice sheets stretched across a large chunk of the northern hemisphere. They covered Canada, extended down into the United States, encased Iceland completely, and blanketed Scandinavia and the British Isles. Some of that ice still covers Greenland to this day. Everything the ice touched, it changed. These glaciers literally carved the geology of these regions, and although many of these glaciers are now gone, they are still shaping the landscape in some ways you might not expect. Here are 5 ways glaciers changed and are still changing the world. That's the kind of niche top 5 countdown you can only get on SciShow. Let's start with some stunning views you might already be familiar with, the Fjords of Norway. Fjords are a brand of American automobiles, with the Mustang being an iconic... Fjords are long, narrow channels of water bordered by towering, near-vertical cliffs. These steep, U-shaped structures didn't develop overnight. They probably started as V-shaped valleys carved by rivers over the course of millennia. But rivers aren't the only thing that can flow. Glaciers can too, like rivers of ice. So when they started to flow from their mountain peaks downslope towards the sea, they would have followed the path of least resistance, such as a convenient, pre-carved river valley. Glaciers are mostly made of ice, but as they flow, they also pick up some pretty big rocks and carry them along for the ride. You know how some birds swallow rocks to help grind up their food? Glaciers kind of do the same thing. The rocks they swallow are pressed against the ground by the weight of all that ice, chewing up the landscape as the glacier moves. Over tens of thousands of years, a glacier gouges a river valley into a fjord and can carve the ground even after a glacier pushes out to sea. These glaciers were massive pieces of ice, heavy enough to sink and drag along the sea floor for a while before forming a floating glacial tongue, which is the actual term for that bit that sticks out off land and into the sea. This eating metaphor is pretty rock solid. When the glaciers eventually vanished, their water didn't just disappear, it melted into the sea. The fjord's U-shaped bottoms, where the glaciers used to rest, were then further submerged. As a result, most fjords plunge deep below sea level, with only their characteristically tall cliffsides surging above the water, and the valleys that are left behind form a map of the glacier's slow-motion downhill treks. Even though the ice melted, all those rocks the glacier uprooted had to go somewhere. They became part of the glacier, flowed with it, and when the glacier melted, were often deposited far from their places of origin. That's exactly what shaped so much of our next example, the American Midwest. When you think of the Midwest, you might picture unending flatness with fields of corn as far as the eye can see. Having driven through Ohio before, it's almost unsettlingly flat. And glaciers have a lot to do with that flatness, because they chewed up the ground as they spread across the land, similar to how they carved all those fjords. And because they stretched so far and wide, this action smoothed and eroded every place the ice went. At one point, the Laurentide ice sheet blanketed the American Midwest, pushing it flat. When it eventually retreated, it left behind a lot of the sediment it picked up along the way, creating a layer of soil that's more than 30 meters deep in some places. But that soil, called glacial till, isn't just flat. Research suggests that glacial till soil is also more fertile, which could help explain why the Midwest became America's breadbasket. Glacial till is rich in nutrients like phosphorus and potassium, as well as micronutrients like zinc and selenium. Experiments have shown that growing in glacial till can improve crop yields, so some researchers are even considering putting it in fertilizer. And while we're still figuring out exactly how nutritious glacial till is and why it got that way, some people argue that the Midwest's glacial past is exactly what shaped it into the agricultural powerhouse it is today. But flatness and productivity aren't the only Midwestern features with glacial origins. Glaciers also formed many of the Midwest's distinct landmarks, like moraines, which are big piles of stone that were deposited at the edge of the glacier. You can spot moraines around Lake Michigan, like the Valparaiso Moraine or the Itasca Moraine in Minnesota. Glaciers can also form drumlins, elongated egg or oval-shaped hills that all face the same direction, like the scales of a dragon. We still don't fully understand how drumlins are formed, but our best guess is that they're formed close to the edge of the ice sheet, and they're all facing the same direction because they're aligned with the direction of the glacier's flow. Horicon Marsh, Wisconsin has one of the highest concentrations of drumlins in the world. Another fun type of deposition are erratics, large rocks that get their name because they're chemically non-native to the environment they're found in. Basically, the glacier picked them up at some point, carried them a long way, then dropped them off somewhere completely new, like an extremely slow alien abduction. They're common in the Midwest, like Waldo's Rock in Iowa. This massive boulder matches the composition of rocks that are hundreds of kilometers away in central Minnesota. And glaciers didn't just shape the scenery around the Great Lakes, they formed the Great Lakes themselves. But before we get to that, all science needs funding, so let's go to a quick break.
If we know anything about you, SciShow viewer, you're curious, and that mentality draws people to the new Brilliant too. Brilliant now offers coding instruction for the AI era. For everyone from 5th grade and beyond, for people with a lot of demands on their time, you can all learn with Brilliant. To get the most out of Brilliant's world-class curriculum designed by experts from MIT, Harvard, and Stanford, they've rolled out a world-class visual interactive tutor. It's the benefit of a tutor without the cost and scheduling. Click the link below or scan the QR code to get started with Brilliant's tutor for free. You can upgrade to premium to unlock all courses, and right now, SciShow viewers can save 20% off an annual subscription at brilliant.org/scishow.
Now, when the glaciers that formed the fjords retreated, all that meltwater flowed into the ocean. But sometimes a glacier melts in the middle of a continent, and that water has nowhere to go. In those cases, the water ends up caught in basins carved by the glacier itself, and voila, you're now the proud owner of a lake. Sometimes we can even determine a glacier's path based on the lakes left behind. For example, paternoster lakes. Paternoster lakes form in a chain separated by moraines. They follow the path a glacier takes when it retreats, like Hansel and Gretel's breadcrumb trail. Essentially, the glacier takes a big step back, depositing stones that form a moraine. It then takes another step back, forming a second moraine. Meltwater gets caught in between those two, then it takes another step back, and so on and so on. While you look at them from the air, they look like a string of beads and actually get their name from their resemblance to beads on a rosary. But glacial retreat doesn't just form cute little lakes. There are enormous glacial lakes too, the biggest of which are the Great Lakes, a collection of 5 lakes between the United States and Canada that together hold a fifth of all the fresh water in the world. Remember the Laurentide ice sheet that flattened the Midwest? Well, it was enormous. In some places, the ice was 3 kilometers thick or more. And in its heyday, the Laurentide covered everything from the North Pole to Pennsylvania. The sheer weight of all that ice carved out the basins that eventually flooded with meltwater and became the Great Lakes. The boundaries of the lakes were then firmed up by moraines, which were deposited by the glacier as it melted. A few millennia later, those boundaries were further shaped by another glacial phenomenon. While the Great Lakes basins were carved out of the earth by the Laurentide ice sheet, the lake boundaries reached their final forms thanks to a phenomenon called glacial isostatic rebound. Those are some big geology words to describe a pretty simple process, albeit one that is happening on a planetary scale. Okay, picture a trampoline. When you sit on it, your weight makes the material flex, and you end up dropping a little bit. When you leave, the trampoline springs back into place. Earth might seem pretty rock solid, but like a trampoline, it's actually elastic. When enough force is applied, it bends. You just need to apply a lot more force than you need for a trampoline, and the bending happens a lot slower. Glaciers as big as the Laurentide ice sheet were heavy. The weight of all that ice squished the surface of the Earth into the mantle, and then when the glacier melted, the ground breathed a sigh of relief and started to spring back up. While the entire Great Lakes region is constantly rising, isostatic rebound helped shape the lake boundaries, pushing everything into the shorelines we know and love today. And believe it or not, this glacial rebound is still happening. For example, Ontario, Canada used to be right underneath the glacier, or right in the middle of the trampoline. That means parts of Ontario are getting taller every year by a whopping 13 millimeters. That's about half an inch a year, which is really fast for a geological process, and definitely noticeable. I mean, if I were still growing half an inch a year, I wouldn't have had to abandon my dreams of becoming a basketball star to be a science communicator. Anyway, but what goes down must come up, and vice versa. While some parts of North America that were weighed down by ice are still getting taller, other areas are still sinking. These areas were once part of the forebulge, the area that got squished out at the leading edge of the glacier. The forebulge was pushed upwards by the weight of the glacier behind it, and now that the glacier is gone, is still relaxing back down. These sinking areas are mostly along the coasts, which certainly doesn't help with the issues of rising sea levels. And this same slow-motion trampoline settling is also happening for our friends across the pond. Most of Scotland is getting a wee bit taller each year, while much of Ireland and England are slowly slouching down into the sea. So far, we've looked at geographical features formed by glaciers grinding, squishing, or melting. But What happens when a region seems to be surprisingly lacking any glacial features? There are some really unique landscapes that came about because glaciers weren't there. Nestled in the glacier-smooth Midwest is a spot around Wisconsin that the glaciers somehow just missed entirely. This region is called the driftless area. It's a pocket of steep rocky bluffs and deep winding valleys, a hiker's paradise in the flatness of middle America. The driftless area gets its name because it's missing the drift, the sand, silt, and debris kicked up by glaciers, and it escaped that deep freeze thanks to its topography. The driftless area is a high elevation zone bracketed by lower elevation areas that turned into Lake Superior and Lake Michigan. The region stuck up above the rest of the landscape enough that the ice sheet flowed mostly around it. Consequently, it was never eroded flat. Then there's a missing river in Washington state's channeled scablands, a region of exposed bedrock marked by suspiciously dry channels. It sure looks like a place where water should be flowing, and there are a couple of rivers around there, but none of them are anywhere big enough to have carved the channeled scablands landscape. Water did flow there once, but it disappeared nearly 20,000 years ago. The scablands were formed when a dam made by a nearby glacier broke. That glacier happened to be propping up an enormous lake called Glacial Lake Missoula. So when that dam broke, all that water came flooding out at once. Over 2,000 cubic kilometers of water ran over what is now Washington state. It was a series of floods so catastrophic that they sometimes reshaped the landscape completely in just a matter of days. These floods happened many times over several millennia, repeatedly re-etching the land before drying up and leaving the scablands behind for us to ponder. There are so many other cool glacial features that we couldn't quite fit in this episode, like Mount Sunday in New Zealand, which some of you might recognize as Edoras, the capital city of Rohan from the Lord of the Rings movies. Mount Sunday is what's called a sheepback mountain and was carved by glaciers once upon a time. Glaciers also form beautiful structures like mountain cirques, deep basins that make them look like volcanoes, not to mention braided river systems and glacial meltwater deposits called eskers, among other stunning natural features. As we've seen, the world is still reshaping after the melting of our ice sheets. New cases of isostatic rebound are also springing up, especially in Greenland, as our remaining ice sheets melt due to climate change. Although most of the Earth's glaciers have been gone for tens of thousands of years, they left us distinctive geographical features that shaped the landscapes and the ways we navigated and settled the planet. Even in their absence, we still see glaciers everywhere.